equals to x squared. What does this graph look like? Wei Hao? What does this graph look like? Hurry up. Is it a straight line? Yes or no? Yes, sir. When does a graph look like a straight line? Straight lines of the form y equals to mx plus c. What's the power for x in a straight line? 1. Is this 1 over here? So it is not a straight line. Now it is y equals to x squared. What is the shape of this graph? Curve. What sort of curve? Well, yes, parabola opening upwards, looking like this. So this is y equals to x squared. Okay? And I am going to show you another equation. Y equals to, okay, change color. Let's use green. Y equals to 2 to the power of x. What's the power of 2? Okay, look at the green color one. One more time. What's the power of 2? X. And then in this purple one, what is the power of x? Okay, are they the same equation? But they look quite similar, right? They just, the x and the 2, they look like they just swap position. Okay, so do you think the graphs will look similar? Then how do we confirm? We plot it out. Okay, oh yes, Afiq says we can use decimals. But let's say I plot it out. And I did some work earlier on. Now, first one, y equals to x squared. Okay, the orange one. That was the first graph that I had. Now the second one, y equals to 2 to the power of x. Okay, now in the purple one, you see that the difference is from your negative values of x, it is very close to, oops. Great, yes. Now the purple one is y equals to 2 to the power of x. When we go to negative values, it looks like it is very close to the y-axis, sorry, the x-axis. It looks like it is touching, but again, it is actually not touching. Okay? Same thing, just keeps going closer and closer to the x-axis, but it doesn't touch. Then, when we increase the values of x, when we increase the value of x, it goes up, it cuts through this point, y equals to 1. Because 2 to the power of 0 is equals to 1. So you must cut through this point. Then, it will increase at a faster rate. Then they meet the curve at, they meet your y equals to x squared at 0.2, 4. Once it goes past that point, then it continues to shoot up. It meets the curve again at 416, and it increases at a faster rate. Okay, faster than your y equals to x squared. What about different values of the base? Maybe let's consider this y equals to x squared. Let's consider y equals to 3 to the power of x. It goes up even faster. Let's see how I can x-axis. Now this is a bit clearer. Your purple one is y equals to 2 to the power of x, whereas your black one is y to the power of 3x. Which one is increasing faster? Which one is increasing faster? Base 3 or base 2? Base 3 is increasing faster because let's say when x is equals to 2, your purple graph gives you y equals to about 4. When the same one, x is equals to 2, your y is equals to 9. So the black graph, y equals to 3x, is actually increasing at a faster rate. And notice over here that they both intersect the y-axis at the same point, 0, 1. Why is that so? Because when x is equals to 0, y will be equals to 1. Over here, when x equals to 0, y is equals to 1 again. Anything to the power of 0 gives you 1. So that is the reason why they intersect at the same point. So maybe just one more example, y equals to 4 to the power of x. I guess you already can imagine what the graph looks like. So again, it will pass through the same point, 0, 1, but it is going to be steeper. It increases at a faster rate. Okay? So now you have learned another type of graph, exponential graph. They increase at a very, very fast pace. Then, let's see what else is required. You can now look at page 134 of your textbook. At the bottom of the page 134, you have this equation, y equals to k a to the power of x, where so many letters, right? You don't even see any numbers. But what I want you to take note is that this x over here is now a power. X is the power. In the previous chapters, your x was the base. Then we changed the power. The power we have learned, -2, -1, 0, 1, 2, 3. Now this time x is the power. So we get exponential graph. Okay? Then what is this? What is this a over here? This is the base. Just now we were looking at base. Just like it was base 2. Then I show you the graph of base 3 and graph of base 4. And this k over here is just a constant. Just a number that we multiply with. But k can be any number. Okay? Now what happens when k is there a difference when k is equals to 0? When k is greater than 0 or k is smaller than 0? Let's see what happens in Desmos. Right now, can you tell me what is the value of k? Yeah, k is equals to 1. You compare that with your... Okay, let me put it side by side. Okay, never mind. Y equals to k times the base to the power of x. Over here I have y equals to 1 times the base to the power of x. So in other words, this is actually 1 multiplied by this lah. No change. No change to the shape of the graph. So over here also, same thing. 1 times, okay, and finally 1 times this. Okay, so for all these 3 graphs, my coefficient, meaning my value of k, is 1. Then the base, which is a, is changing. I have 2, 3, and 4. Then the power, x, all the same. Okay, no matter how I change this value over here, as long as it is positive, generally the shape will be the same. Let me just hide this first. Concentrate on this one. I'm going to change this to another positive number. For example, 2. Okay, you see that there's a slight change in the shape. Not too drastic. Okay, I am changing with all these positive numbers. Okay, for example 11, for example 4. Okay, what do you notice about the y-intercept? Right now, what is the y-intercept? Y-intercept 4. The y-intercept is 4. Do you know why is it 4? Because when x is equals to 0, what is 2 to the power of 0? 2 to the power of 0 is 1. 1 times 4 gives me 4. So that's why the y-intercept becomes 4 when the coefficient is 4. So what happens when the coefficient is 7? When coefficient is 7, y-intercept is 7. Okay, why is that so? When we are talking about y-intercept, we are finding the point when x is equals to 0. Okay, Hoi, when x is equals to 0, what is the value of this highlighted part? 2 to the power of 0, what do we get? 1, right? Rabiato, 1 times 7, what do we get? 7. So when x is equals to 0, y is equals to 7. Okay? Now, if I change this to 24, okay, I change this to 24, without looking at the y-intercept, can you tell me what is the value when x is equals to 0? How much is it when x equals to 0? 23. 24. Why is it 24? 2 to the power of 0 is 1. 1 times 24 is 24. Let us verify. And as expected, y-intercept is 24. Any questions about y-intercept so far? Yes? I don't understand your question. No, we take x to be 0 only to find the y-intercept. Okay? So it doesn't matter what these values are. I mean, it can be even half, 0.5 over here. Okay? Let's say it is 0.5. It is smaller than 2. But if I want to find the y-intercept, it is the same logic. X equals to 0, 2 to the power of 0 is 1, 1 times 0.5 is 0.5. And it intersects at 0.5. Okay? We have seen how a graph changes based on its coefficient, meaning this value of k, as long as it is positive. So even this one, y equals to 3 to the power of x, intersects at 1 currently. If I change this to maybe 7, you will have y-intercept as 7 again, because 3 to the power of 0 is still 1. 1 times 7 will give you 7. Okay? Method for finding y-intercept does not change. Now, I'm going to just show you a few more examples. Okay? When it is equals to 2, the graph looks like this. When it's equals to 8, like that. When it's equal to 10, looks like this. Generally, the shape is the same. Yeah, okay, Afi has asked the question, what happens if it is negative now? Look at how it changes. Negative 3. It now bends downwards. Okay, one more time. When it is positive, it goes upwards. When it is positive, then when it is negative, it goes down. Okay, how does it change as the number becomes more and more negative? Right now it is negative 2. When it becomes negative 5, it bends down even more. When it is negative 9, it bends down even more. Are we able to find the y-intercept in the same way? Yes, we can. For example, when x is equals to 0, what is 3 to the power of 0? 1. 1 times negative 9 is negative 9. Yellow? I can change this to negative 4. Then my y-intercept will be negative 4. Okay? Solution to, you see, when you ask the question, which one is the solution? This is a graph. There is no solution to talk about. unless I give you an equation with one unknown. And then there is a solution to talk about. Or I give you two equations with two unknowns. Then you have solution to talk about. Right now, this is a graph of y related to x. Meaning, for any value of x, I will have a corresponding value of y. No solution to talk about yet. Okay? Yes? Okay. So this is on your textbook, page 136. Textbook, page 136. We have two types of graphs shown at the top. The first one is when coefficient of the base is positive. So this is y equals to k a to the power of x, where k is positive. How did they write that? They wrote down k greater than 0. Okay? K greater than 0 means k is positive. So it slopes upwards. What is this intersection point over here? What is this intersection point? Anybody wants to try? Okay, Alfian says it's a positive number. Yes, I agree. Because I said k is greater than 0. But what is this value here? Can I say it is 1? Is it 1? Is it 2? Why is it 2 but not 1? Can it be 3? So what exactly is it? Huh? I think I heard the answer already. What is the value of this intersect? K. Yes, it is k. Right? When, let's look at this one. When x equals to 0, y equals to k a to the power of 0. This is k times, how much is a to the power of 0? 1. So you get k lah. Okay? Like what we have been doing earlier on, I show you all the different variations of the coefficient. Let it be 7, let it be 11, so on and so forth. Then this intersect will just take that value. And this is mathematically y. Okay? Then, now, the graph on the right hand side is your y and x. So y equals to k a to the power of x, but now k is negative, meaning k is smaller than 0. Our graph looks like this. It slopes downwards, doesn't touch your x-axis, and it cuts through this point. What is this value here? What is this value? Negative k? You all agree? Is this equals to negative k? Agree, yeah? Agree? Agree? Ifina, you agree also? Xiaowei, do you agree? K is a constant, yes. Negative k is also a constant. Xiaowei, do you agree that this is negative k? He said, okay, what do you think it should be? Okay, he don't know. He doesn't know. Okay. It looks like it should be negative k. But let us refer to this. K is smaller than 0, right? So k is like, for example, negative 3. It's negative 4, negative 5. All these are possible values of k. What is the value of negative k then? Let's assume that if k equals to, give me a negative number, any number.
Negative 5.
Negative 5. If k equals to negative 5, then what is the value of negative k? Equals to 5, right? So you are telling me that this is equals to 5, Possible or not? No, right? Because 5 is supposed to be up here. This should have been a negative number. In other words, this should be k. Because k is already a negative number. If the x is negative, then? Oh, are you asking about this case? Ka power negative x? Okay, that one next time, okay? Right now we concentrate on this one. This one is quite enough already, Oops. Okay, the y-intercept will still be k. But this time, just keep in mind that k is already a negative number. Because k could have been, for example, negative 5. Okay? If k is negative 5, then this value will be simply negative 5. Alright? Okay, now, with all this information, does anybody have questions? Besides Weihao's question of what happens if it is power negative k? Very good, you all are thinking of all the possible types of graphs that there could be. But this one, I don't think it is not in your syllabus. Okay, because it gets quite complicated. So, any questions for all the different graphs that we have learned for this semester? If don't have, I want you to try page 140. Page 140 is a class activity. You can work, you're already seated in your pairs. Just assign which graph matches which equation. So yeah, basically you just need to know the shape for the different type of equation. Okay? Then we'll see how many you guys got correct.